Welcome back. Here we'll discuss further thing about viscosity. We should know that all the fluids may not follow Newton's law of viscosity. What is Newton's law of viscosity? Tau is directly proportional to velocity gradient. If you remember, that is what is law of viscosity defined by Newton. And in the picture also, if I represent a velocity gradient du by dy on x-axis and the shear stress on y-axis tau, and if it is a Newtonian fluid, in the sense tau is directly proportional to du by dy, if that is the thing, then I'll be getting all the points on a straight line and the slope becomes mu, or coefficient of viscosity. So this blue line indicates Newtonian fluids, in the sense the fluids which follow the Newton's law, but not necessary that all the fluids existing in nature may not follow Newton's law of viscosity. The law says that shear stress is directly proportional to velocity gradient. Because of that, tau is equal to mu into du by dy. But in general, if observation is made of variation of shear stress with respect to the applied change in rate of strain, we get an equation tau equal to mu into du by dy raised to n. The power of shear rate strain is n. Now if you look at the figure, the when n is equal to 1, it will be a line like that, blue line like that, and then we say that all the fluids which follow this particular equation will be referred to as Newtonian fluids. Example is simple example. I have given one example for each one. It is water. Water follows perfectly tau equal to mu into du by dy. Now, if n is less than 1, then it is referred to as, means maybe this value is 0.7, 0.8, like that, then it will be referred to as a pseudoplastic paint, or whatever way the paint behaves here. You know that how thick the paints are, oil paints are. Now it follows something like this. It starts with 0 only, but curve will not be straight line. It will be continuously rising, but the rate of rising will be less and less continuously. So if n is less than 1, then it is termed as pseudoplastic, or it is also called as shear thinning, and example is the paint, oil paint especially. Then another case, if n is equal to greater than 1, if n is greater than 1, then it indicates dilatant fluids, and example is starch. So when n is greater than 1, it will be rising continuously. So the curve that is followed is in the yellow color here. So these are called, the fluids are referred to as the dilatant fluids. So obviously the fluids which is represented by either yellow or even this different kind of blue, they are non-Newtonian fluids. They are non-Newtonian fluids. Okay. Now, if initially some minimum shear stress is required to start the strain, means it won't start at 0 point. Means even if the motion is required, you have to apply a greater minimum amount of force. Means here it starts deflecting or changing its shape. So tau minimum is required. In such case, then it is classified as Bingham plastic. And the best example or familiar example is ketchup, right? And it is also referred to as viscoplastic material. Then last one, if no shear stress is required to cause deformation, means without any shear stress, the liquid can deform, or the fluid can deform. If no shear stress is required to cause deformation, then it is ideal fluid. In the sense, the tau is zero, but you can observe the shear strain. So the plot will be along x-axis. So such fluids, uh, we can say that they don't have any viscosity. If there is a viscosity, then there will be rise. More the viscosity, it will be on the higher side, depending upon the position over here. But if it is completely flat, then there is no resistance, or viscosity is not there. Such fluids will never be existing in the nature. Almost every fluid will be having some or the other viscosity. Maybe some of them are very less, some of them will be possessing a very high viscosity, right? If it is not uh, having any viscosity, then it is an imaginary fluid. We call it as ideal fluid. So if no shear stress is required to cause deformation, then it is classified as, or it will be recognized as ideal fluid, where mu is equal to 0. It is an imaginary fluid. All other fluids, means leaving this one, which is a flat curve, ideal fluids, all other fluids, all of them are referred to as real fluids. The real ones means as existing in nature. Okay, there we'll stop. Thank you.